Hi everyone. In this video, we study about tie-set matrix. Tie-set, tie-set matrix or fundamental loop matrix. Fundamental loop matrix. Right? Okay. So we know that. Let us take first one graph. I take this graph as usual. I am doing this. This is nodes or vertices and edges, right? From the graph we can draw tree, right? So tree is a subgraph which contains all the nodes but no loop. So I draw this tree. It contains all the nodes but no loops, and we know that the tree branch is known as twig, right? And co-tree is complement of tree which is formed from the branches which have been left. So this green color is talking about co-tree, and branches of co-tree is called link. These things we have to remember, right? So this is one link right here. So this is another link, this is another link. This we know, right? Now I draw the tree again. In tree, if we add link between two nodes, it will form a loop, right? I am adding one link. See, the first this is tree and this is code tree, right? And this is code tree. So this is one link, this is one link, this is one link. If you add link between any two nodes, it will form a loop. You see now it has formed a loop. Similarly, if you add one link between these two nodes, this is one loop. This is another loop. Similarly, if you add one link between two nodes, it will form another loop. That is closed path. Right? This loop is known as fundamental loop. Right? So I can I can express this loop in the form of matrix. That matrix is called fundamental loop matrix or tie-set matrix, right? So tie-set matrix or fundamental loop matrix are same. Now we go and know how to write a fundamental loop matrix or tie-set matrix. Let us take this our tree and vertices. Now we have to know some important point. Let us assume, no need to assume, we know that our loop has how many branches? Let us assume this is branch number 1, branch number 2, branch 3, branch 4, branch 5 and branch 6, and let us take this is a directed graph. This one, this one, this one, this one, right? And it has 6 branches and 4 nodes or vertices, right? Vertices or nodes on the, it is 4, right? So how many links in the code tree? That has been found by using the formula b minus n minus 1. See, from this we have drawn a tree. This red color is a tree, and we know what are the links. Links is nothing but a branch of a code tree. This yellow color is talking about code tree, and this code tree has 3 branches. So 3 link. This is one, this is one, this is one. 3 links. Total nodes 4. So branches of my graph is 6, right? And branches are 4 and minus 1, that is equal to 3. So 3 links. Number of links can be expressed in the form of b minus n minus 1. Why I write L is equal to b minus n minus 1? L is equal to link. Link is obtained by subtracting number of twigs from the branches. Yes, twigs are nothing but the branches of tree, whereas links are nothing but the branches of tree. So if you add links and twigs, we will get total number of branches. So from here you see total number of twigs are 1, 2, 3, right? So if you are having 4 nodes, surely you are having 3 trees. That means if you are having n nodes, we will have n minus 1 tree branches or twigs. That is well known, right? From the diagram also you will understand. Here we are having 4 nodes, so we have 3 twigs, right? So the tree formed from these 4 nodes surely will have 3 twigs. If you are having 4th twig, surely it will form a loop. A tree should not contain loop. So L, if you subtract a number of twigs from the branches, what you get is number of links. So that's why I have substituted L is equal to b minus n minus 1. That we must know. Now we will go and write fundamental tie set matrix. Right. So again I take the same loop because that is easy to draw. Right. That's for simplicity. And this one. And this is right. Same color I am giving. This is branch 1, this is branch 2, branch 3, branch 4, branch 5 and branch 6, right? Whatever I am drawing in red color is my tree branch. Whatever I am drawing in yellow color is my co-tree branch. Now how to write fundamental tie set matrix? That is a matrix drawn from the tree, right? So tree I have, if I am adding one link to every branch of tree, what I am getting is, this is one thing. So your tie set should have one link. That is another important point. Tie set should have one link only, and it may have 2 or more branches. That is not a problem. So it should have one link, 2 or more twigs, right? So let me take one link, right? And it may have the loop, fundamental loop may have 2 or more twig. So here you see, this is a fundamental loop. This is one fundamental loop. And second fundamental loop is this one, right? And third fundamental loop, how can I draw? Let me draw the third fundamental loop. It will be like this, right? So how to form a fundamental loop? Fundamental loop is formed with only one link, right? So only one link should be there in a fundamental loop, and it may contain 2 or more twigs, right? Link is a branch of a co-tree, and twig is a branch of tree. And we must know how many tie sets we can draw for any tree. So that there is one relationship for that. Number of tie set we can draw is equal to number of link. So we know our co-tree has 3 links. So we can draw only 3 tie sets. So I have drawn this tie set 1, tie set 2 and tie set 3. Now I write fundamental tie-set matrix. I note direction. This is like this, this is like this. So this is going like this, this is going like this, this is going like this, this is going. It is, this direction is drawn from main graph, right? So now I draw tie-set matrix. So tie-set matrix has rows and columns. The rows represent number of link. So how many links we have? We have 3 links. That is, what is the equation for a link? B minus n minus 1. Rows are representing link, columns are representing branch. So what is the order of the matrix? B minus n plus 1 cross B. This is the order of your tie-set matrix, B minus n plus 1 cross B. So row represents link, column represents branch. Now we take, what are the links we take? What is the link number? Link number is, what is the number I have given? So it is 1, this is 2, and this is 6. So link is 1, 2, 6. So I write link 1, link 2, link 6. Fine. Branches 1, 2, 3, 4, 5. Total I take. So let us go to first set. What is that? You see this one fundamental, this fundamental loop. What is happening? How to fill the element of matrix? If loop is going in the direction of, if the branches are going along the direction of link, you add plus 1. If the branches are going opposite to the direction of link, you add minus 1. So we know that, sorry, first I write numbers for this. 1, or first it I said 1, 4, 5. So yeah, this is 1, this is 4th branch, this is 5th branch. If the branch is going along the direction of link, you put plus 1. If the branch is going along the opposite direction of link, you put minus 1. Here branch 4 is going along the direction of link 1. Here the link is 1. So 1 and 4 are having same direction. So I put for 1 also plus 1, for 4 also plus 1. Link is always plus 1. And 5 is going opposite to the direction of link 1, because link 1 is traveling like this, and link 5 is, sorry, branch 5 is going opposite, whereas branch 4 is going along. So the link 1 plus 1, link 4 is opposite to link, going along the link 1, so plus 1, link 5 is opposite. So 1 and 4 are plus, 1 and 4 are plus 1, 5 is opposite, minus 1. So we are having 6 branches, so I add 6th branch also, right? Next, remaining things are not available for calculation, so we put 0, 0 and 0. Next, go to link 2. This is my link 2. So this is link 2. This is 3. This is 4, right? Yes. Link 2 plus 1. Link 3 is along the direction of link 2, but link 4 is opposite. So 2, 3 plus 4 is minus. 2 and 3 are plus. 1, 1, 4 is minus. Rest of the things are not available for calculation, so we put 0. Next, this one. So I assume this is a loop tie-set 2 or tie-set 3. Anyway, you can take. Here I have taken, this is a tie-set 2. This is tie-set 3 in the matrix, so I change. So tie-set 3, this is 6. This is 3 and this is 5. So 6 is a link, so plus 1. 3 is also going along the direction of 6, so plus 1, but 5 is opposite. So 3 and 6 are plus, 3 and 6, 3 and 6 are plus, 5 is minus. Rest of the things are not available for calculation, rest of the branches. So this is my fundamental tie set matrix. So number of twigs is, number of link is 3 and the number of branches are 6. So it is a 3 by 6 matrix. I hope you understand the tie set matrix very clearly. If you are having any doubt, you can ask in comment section. Thank you.